We talked about limits in chapter 0, and we said that a limit is the value on the y-axis that the graph of f of x approaches as you approach x equals a specific value. So for example, suppose I'm looking at x equals c. As I approach c, I ask myself what value on the y-axis is the graph of f approaching. Now remember, all we care about is where on the y-axis the graph is intending to go. Okay? So if I look at this, if I approach c from the left side, my graph seems like it's decreasing to this point L. As I approach C from the right side, it looks as if my graph is approaching that point L. Okay, it's ascending to that point L. Whether or not the graph actually gets to that point L is irrelevant. What I care about is that it has the intention of going to this point from the left, and it has the intention of going to this point from the right. When it's approaching the same point from the left and the right, we say the limit exists, and the actual value of the limit is the value on the y-axis where the graph is approaching. So in this case, because it's approaching L from the left and it's approaching L from the right, we say that the limit as x approaches c of f of x is L. Okay? The analogy I like to use is, suppose you're standing on the x-axis and you're walking this way towards c, and you have your eye on the graph the entire time. As you're walking this way, you're looking at the graph, and you see the graph going further and further up towards that point L. Okay, that's what we need to look at. All right. So let's estimate the limit of this function using a graph, and we want to support our answer numerically using a table of values. What we're going to do first here is graph this. We can easily graph y equals 4x plus 1. However, what I'm going to have to do in order to get a valid number here is go up by not ones, by 4, so this will be 20 and this will be 40, and similarly here, negative 20 and negative 40. Okay? So when I graph now, when x equals 5, this equals 21. When x equals negative 5, it will be negative 19. When x equals 0, x is equal to y is equal to 1.
Where did that 0 come from?
I'm just plugging in points. Okay. Now, our question is, what is the limit as x approaches negative 7? Negative 7 is here. So as x approaches negative 7 here, we want to see where the graph is approaching, and it looks like it's approaching a value of negative 24 if you look at the graph closely.
I have a question. You said that x approaches negative 7. Why do we know it from the left to the right? Is it just always like that?
So we have to look at it from the left. Now, we said that from the left, it looks like it's approaching negative 24 if you've drawn the graph accurately. And if now you have to look at it from the other side as well. And it looks like it's approaching negative 24 from that end as well. Okay? So it looks like my answer will be negative 24. So I say limit of 4x plus 1 as x approaches negative 7 is equal to negative 24. Now, let's see if we can support this numerically. As I'm approaching negative 7 from this side, okay, what are these values here? This is negative 7.01, and if I get closer, I get to negative 7.001, negative 7.00001, and so on, right? So let's plug in negative 7.01. And the way you can do that very quickly is if you have your calculator and you plug in there 4x plus 1. And we want to adjust our windows to the y from negative 40 to positive 40. Now, when I'm in trace mode, I need to plug in negative 7.01, and that gives me a y value of 27.04. In trace mode again, I plug in negative 7.001, and it gives me a value of 27.004.
Yeah, but how did you get 24?
Yeah. You got 24 from before.
Oh, I should have, I'm sorry, it was 27. I'm sorry, 27.
I actually get 27. Like, how do you?
Because you
eyeball
plug it in.
27.
You just eyeball it?
Yeah.
It's a reason, but it's only, I think.
Once you fill out your chart, you see that as x approaches negative 7 from this side, the values are approaching negative 27. And as x approaches negative 7 from this side, the values of f are approaching negative 27.
What do you mean the values of f?
Okay? The values for f of x are approaching 27. Negative 26.6, negative 26.9996. The next one is going to be negative 27. So we just confirmed what we had stated from the graph numerically using the chart, a table of values. Okay? Now, if we actually plug in negative 7 into the calculator or into the equation, what does it give us? What value do you get?
27.
Negative 27. Okay, now it's irrelevant. The fact that whether you get a value, whether you don't get a value, whether you get a value of negative 27, it's irrelevant. What you care about is that as you approach negative 7, you're approaching a certain value here. And as you approach negative 7 from this end, you're approaching the same value from there. Okay? All right, let's go to the next problem. Before we do that, here we have 3 different graphs of f of x. Okay? Let's look at the first one. Suppose I ask you what the value of f of c is. What is the value of f of c here? So when x equals c, what is y?
1.
There's a hole there, so it doesn't exist. It's undefined. Okay? When x equals c, you follow it up, there's a hole there. That means there is no value. It's undefined. All right, what about this one? When x equals c, follow it up. What is the value of the graph at x equals c?
Same thing. N.
It's n.
Why?
Because if you follow it up, you have a point here. That's the value of the graph. Okay? So here, g of c is n. All right, what about here? This is x equals c. What is y?
No.
L. Okay? Now, in each of these cases, the value of the function is different at x equals c. Here, it doesn't exist. Here, it's something off of the graph. Here, it's actually on the graph itself. Now, I now want to see what the limit is. So now let's look at the limit. In this case, as I approach c from here, where is the graph going?
Positive.
To L. Right? As I approach c, the graph is approaching L. Here, as I approach c from this end, where is the graph approaching? To L. So the limit here is L. Look at this case. As I approach C, which way is the graph approaching? To L. As I approach C this way, my graph is heading up towards L. If I approach C here, my graph is going towards L from this side and from that side. Okay? In all three of these cases, the limit is L, but the actual value of the function is three different things. So just another way to show you that the two are completely independent from one another. Okay? We need to graph this equation. We're going to plug it into our calculator. It is x squared minus 16 over x minus 4. So essentially the graph is going to look like this. And okay. All right. So the question asks, what is the limit as x approaches 4? If I'm here and I'm approaching 4 from this side, where is my graph going? Up to what value? 8. Okay, it seems it's going up to 8. Now, as I'm approaching 4 from this end, where is my graph going?
8.
Down to 8. Okay, so it seems the limit of x squared minus 16 over x minus 4 as x approaches 4 is equal to 8. Let's verify this using a table of values. When you plug in 3.99 into the trace mode, you get a value of 7.99. 3.999 closer to 4 gives you 7.999. So, okay, obviously, as I approach 4, I'm approaching 8 on this end. Okay? On this end, 4.01 gives me 8.01. 4.001 gives me 8.001. Again, I'm approaching 8 on that end as well. Okay, so I've just confirmed it. Now, what happens when you actually plug in x equals 4? It's undefined because this isn't the way the actual graph looks. In reality, the graph has a hole at x equals 4, y equals 8. Right there. So that's what the graph looks like. When you graph, that's what you need to graph. Okay? This is why if you changed it to just x plus 4 and plug in x plus 4 in the calculator, it won't give you that blank when you plug in x equals 4. Okay? Yes?
But for that, what was in the limit of f?
Sometimes it's worthwhile to look at a limit from one side only. Alright? So just approaching a number from the left side or just approaching a number from the right side. So for example, in a case like this, if I'm just interested in where the graph is heading as I approach it from the left side, okay, that might be all I need. Now we have notation to distinguish left and right side. The notation looks like this. If I have x approaching c with a minus on top, this represents the value of a function as you approach from the left side. So think of it as you're approaching this way from the side of the negative numbers. If I've written it this way, x approaches c positive, now you're approaching from the side of the positive numbers, you're approaching from the right side. Okay? So the theory is that if you approach a limit, if you approach a value from the left side,